Welcome to qnawire.
We need to find the center of gravity of the given table. So to find the center of gravity, which we're going to call y bar, the center of gravity on the y-axis, we're going to need to find the mass of this figure and also the center of gravities for these different areas of the table. So this center of gravity y is going to be equal to the summation of the center of gravities on the y-axis for the different areas times the mass m divided by the summation of those masses m. So we're going to start by finding the masses of these different locations 1, 2, and 3, where 1 represents this quarter circle here, and 2 represents this quarter circle at the top, and 3 represents the table. So the mass m1, this is going to be equal to the density of the steel tube times the cross-sectional area times the length of that quarter circle. And then we can also write this as rho times A times pi r over 2. And so the density is given as 7,860 kilograms per meters cubed. The cross-sectional area is given as 150 millimeters squared, and the length r is given as 180 millimeters. And so the mass of that first area is going to be equal to 0.333 kilograms. And now M2, so this area of M2 is also a quarter circle. So we're going to use the same formula for M2. So M2 is equal to rho times A times pi r over 2. And so we have similar values except for r. And in this case, r is going to be equal to 280 millimeters. So we plug in the new value for r. And so the mass of the second area is equal to 0.518 kilograms. Now for the mass of the third area, this is going to be equal to the density of the glass times the area of the glass table, and then times the thickness of the glass table, which we'll call T. And so we plug in the density as given. We can plug in pi over 4 times 600 squared millimeters squared for the area. And then we can plug in 10 millimeters for the thickness. And so this will give us a mass of 6.1 92 kilograms. And so next, we need to find the center of gravities on the y-axis for those different areas 1 through 3. And so we're going to start with y1. So y1 is equal to 12 plus r minus 2r over pi. So we plug in the given value for r, which is 180 millimeters, and then do the same thing here. And so the center of gravity for that first area is equal to 77.41 millimeters. And now for y2, this is going to be equal to 12 plus r plus 2r over pi. So we plug in 180 millimeters for r, and then we'll get a center of gravity of 370.25 millimeters. And now finally, y3, this is going to be equal to 24 plus 180 plus 280 plus a thickness t divided by 2. And we know that t is equal to 10 millimeters. And so plugging in t, we'll get a center of gravity for y3 that is equal to 489 millimeters. So now we have all the masses that we need, and the summation of those masses that we calculated, which was, so it's going to be m1 plus m2 plus m3, and this mass is equal to 8.748 kilograms. And we can also say that the summation of the center of gravities on the y-axis times the mass m is equal to 3,681.3 kilograms millimeters. And so we're going to go back to the formula that we wrote down for the center of gravity y. So we now know what the numerator is and what the denominator is. So now it's just a matter of plugging in the known terms. So this center of gravity, this is going to be equal to 3,681.3 for the numerator. And now for the denominator, we plug in 8.7 and 48 kilograms. And so the center of gravity is going to be equal to 421 millimeters.